In this video, I will tell you about a study in digital humanities, a network analysis of the Da Vinci Code by Dan Brown. The purpose of the exercise is twofold. First, I will show you how to apply network analysis, an advanced data analysis technique, to a seemingly unrelated area, film adaptation, traditionally associated with creativity and good knowledge of English rather than Python. Second, I will do a film adaptation of the Da Vinci Code, that is, prepare the book for conversion to a movie script. I will identify core actors and places, identify relationships between actors and places, and identify groups of actors, so-called clusters. Most intriguingly, I will do all of the above kind of without reading the book. All I need for the study is the text of the book, and knowledge of text analysis, network analysis, and some programming language, say Python, to stitch them together. You can learn these skills from my books, Data Science Essentials in Python and Complex Network Analysis in Python, published by the Pragmatic Bookshelf. Any text analysis starts with an electronic document. Here's a 2-paragraph excerpt from the end of Chapter 3 of the book. I will use it to illustrate several important concepts. The first step towards automatic text structure discovery is named entity extraction. A named entity is a reference to an actor, place, company, or organization, something or somebody that has a name. Python provides specialized tools in the module NLTK for locating named entities. There are several potential problems with named entities. Some entities, such as Neanderthal, are of no interest to me. Some names refer to more than one entity. What if there are 2 captains in the book? Some entities are known by more than one name. Bezufash is also known as a captain. Finally, some entities are anonymous. They have no names at all. Who is a he? For the sake of simplicity, I will disregard all of these problems. Once the entities are recognized, I will detect the co-occurrences. 2 entities co-occur if they are frequently found in the same paragraph or chapter, or on the same page, or within a certain distance from each other. Depending on the definition of the co-occurrence, I will get slightly different results, but hopefully not too different. It is time to construct a network of actors and places. Each circle, or node, represents an actor or place. 2 nodes are connected with an arc if they co-occur in the book. Incidentally, the thickness of the connections represents the strength of the co-occurrence, and the node size represents the frequency of the references to the entity in the text. Enter community detection, a network analysis technique for identifying dense node clusters. The book apparently has 3 clusters painted in different colors. I could use the most frequently referenced entity as each cluster's name, but I will be more intelligent and try to generalize. The blue cluster is detective, the orange cluster tells the mystic side of the story, and the green cluster is all about the conspiracy. I identified 3 groups of actors and places. If I'm a movie director, I can immediately make 3 movies, or 6 if combinations are allowed. However, I can do even better by calculating each entity's betweenness centrality, a measure of the entity's importance. The higher is the centrality, the more important is the entity to the plot. Given a fixed budget, I can concentrate only on the most important actors, or perhaps the least important because they must be cheaper by the dozen. I held my promise. I built a blueprint of a not-so-trivial book with several dozens of characters acting all around Europe in an almost automated way, all thanks to Python, text analysis, and network analysis. Once again, you can learn all these skills from my books Data Science Essentials in Python and Complex Network Analysis in Python, published by the Pragmatic Bookshelf.